Hey guys, it's the week 5 review. So we'll be going over the week 4 task, design and implement basic neural network in TensorFlow. So that's a pretty simple statement, but we had some problems on the back end. The server, which hosts the Mongo database, can't quite keep up with the requests coming in and going out. So top left here, we've got the Python program from the first week running, or I guess second week. It works well, except that the Mongo database can't keep up with the request. So that's a problem. You can see here, bottom right, CPU usage, pretty much maxed out. Number one process, MongoDB at 180% CPU. And this probably could be I/O limited because the hard drive in this machine is pretty crappy. And then below that is Andromeda, the actual data collection program, using about 12% memory, which is good. It had a bad memory leak. Yeah, so that is working. It does work, right? So then we'll move on to what's happened this week. This is the neural network training, I guess, pipeline. We connect to the epoch, or I guess, no, actually the data set that we're collecting data on. And then I have hard-coded a trade pair. I was picking it randomly, but I figured using one in particular would be a better start, so I could kind of train the model to work with one pair and then start branching it out from there. So we get the data, we get a solution, which is basically the next frame in the data. We extract data from the data set into these sort of specialized arrays, and then we pass that data into the input layer of the network, and then this one. Yep. This is leftover code from a example that I use, which no longer does anything. This is the model we're using, and it's a really primitive kind of just multiply everything by itself and see what comes out the other side. Definitely not the final model we'll be using in the output, but good for proving that the network works and that we can actually pump data through it. And then down here we actually launch the session and we start training. We're doing 100 iterations of training. And then there would be an event here where we run the session for computation to get the answer. But I come into that because the network doesn't quite work yet. So for transforming the data, there's a problem, because if we pull in data from the MongoDB, we could be missing entire chunks of data due to network. We could be missing keys from certain elements. So we propagate forward through the data set to copy keys from the left into the right. So that takes care of that side. And then once we reach the end, we go backwards and we propagate keys from the right to the left. So there's forward patching and back patching. And that ensures that we have a data set which meets the shape that we want. If there's elements missing from price, or elements missing from number of sales, or elements missing from open volume versus closed volume, then we can't really correlate data. So we have to have the same number of items per data set. So the forward patching and back patching gives us a good data set. So we'll run the network. Oop. Interesting. Appears to be a Linux problem, maybe. Let's see, Python. Okay, nope, yep, something weird. Who knows? Alright, so we're getting data from the server now. There's an epoch span mismatch saying we received 95 items, but we wanted 100. So then we have to fill those gaps in. That's the code I showed before. And then you see all this forward patching and back patching. That's, plugging the holes in. And now we're actually running TensorFlow. We are iterating through training sessions to train the network to do something. The cool thing about TensorFlow is while you do this, you can also log the data. So now we're done, and we'll Control-C. Okay. And then we'll launch a thing called TensorBoard. Okay, it's running on localhost 8606. So with TensorBoard, you can visualize the network and what it was doing. So right now it looks pretty terrible, and this is not anywhere near what I would want for the end. But the cool thing is you can view the topology of the neural network. And this is actually pretty cool. So you can look at, we've got ask weight, by weight. So ask and bid. So ask weight and bid weight are, you would ask for a price or bid for a price. And then you've got a buy weight and sell weight, which are things that have already occurred. And then the change weight is what happened in the last hour. And so basically we're just multiplying all these together into this gradient descent function. And that would spit out kind of a cost. Well, you provide it the cost function, which is basically find the next value that I've given you from the training set. And so, it looked like we prove here that we have a working network model. We need to expand on this model, which is what's coming up in the next. And actually, backpropagation and training, that already works because with TensorFlow, you get training and modeling in one. So I've kind of these two are kind of combined into one, but really week 5 should turn this network into something that actually works. And, can give us some market data analysis. So, be working on that. Thanks. Bye.